In the figure below, what is the area of the triangle inscribed in the semicircle drawn in the xy plane? So here we can see that we have this semicircle and there is this triangle drawn. Then the very first property suggests that this angle will be 90 degrees, because in semicircle, if you draw a triangle with two ends of the with two vertices of the triangle on the diameter, then the hypotenuse of the triangle becomes the diameter and the angle at the circumference becomes 90 degrees. Now, in this case, we also can see clearly that this particular distance is 4 units, because the x coordinate here is 4, while the other point is 2 units to the right. So this entire length will be equal to 6 units. So if I mark this triangle by the points A, B, C, then we can say that triangle ABC is a right triangle with AC is equal to 6 units. At the same time, now we need to understand that the moment we draw this perpendicular, let's assume that this particular line is BD. We are marking this point as D. So this also is a right triangle. BCD is a right triangle, and this right triangle is actually similar to this bigger triangle. We have these three triangles here, triangle ABC, and that will be similar to triangle BDC, and that will be similar to triangle BDA. So all these three triangles are similar. I'm going to quickly prove that. For example, if I say that this angle is angle, let's call it P, then this particular angle will be 90 minus P, because sum of these three angles is equal to 180 degrees and this one angle is 90, so sum of the remaining two angles is 90. If this is P, this becomes 90 minus P. In the triangle BDC, if this angle is 90 minus P, the remaining angle will be 90 minus P, and that becomes P. And similarly, since we have this angle 90 and this angle P, so if you look at triangle ABD, one angle P, one angle 90, that means the third angle will automatically be 90 minus P. So that way we have proven that all these three triangles are similar. Now, why we are doing that? Because to answer the question, we need to find out the area of this triangle. We already have the base, which is 6 units. We only need to know the height. So the only question that we have now is to find out the length of BD, because the area of triangle ABC can be written as half of AC multiplied by BD, while AC we already know is equal to 6. So we are only trying to find out the length of BD. So now we are going to use the similar triangle property. Okay. So what we can say is that in this particular triangle, we know that this dimension is 2 units, because CD is equal to 2 units. And this particular triangle has this particular dimension equal to 4 units. So we are taking these two smaller triangles to take the ratio of the corresponding sides. The reason is we know one of their sides and one side is common among them. So I'm going to write the sides of triangle BDC in the numerator and sides of triangle BDA in the denominator. So in case of BDC, I'm taking one of the sides that is equal to BD, because that's what we need to find out. And the second side that I want to take, I will take that to be AD. Now, BD is the side in this triangle which is opposite to angle P. So the side opposite to angle P in the other triangle will be DC. So for this triangle, the corresponding side will be DC, and AD is the side opposite to angle 90 minus P, while in this other triangle, the side opposite to 90 minus P will be BD. So that way we can say that BD square will be equal to AD multiplied by DC, while AD we know is 4 units and DC we know is 2 units. So BD square is equal to 4 multiplied by 2, that is equal to 8. So BD can be calculated as square root of 8, which is 2 root 2. So the area that we needed to find will be equal to half of 6 times 2 root 2. 2 gets cancelled out, so final value that we have is equal to 6 root 2, and the answer to the question is option C. So here we needed to use the similar triangle property. We have used the ratios of the similar triangle, the corresponding sides between these two similar triangles, the two smaller ones, and we have got the unknown BD to find out the area of the triangle ABC. I hope you enjoyed the explanation. Thank you so much.